When a battery is disconnected or a module is reset, some diagnostic trouble codes may appear unexpectedly. In this lesson, we'll explore what really triggers these codes, what your ECU actually sees after a reset, and why simply replacing parts can lead you astray. Let's break down a proven approach you can use right away. After a battery or module reset, the ECU starts with a clean slate. It needs to see certain conditions like sensor power, grounds, and signal plausibility before it can reliably check for faults. If any circuit path isn't fully restored or reinitialized, the ECU may flag a code even though the real problem is connection, not a failed part. Modern ECUs use plausibility logic. They don't just check if a sensor signal is in range, they compare related values or check for agreement between sensors. For example, a throttle and pedal sensor might both need to show consistent changes before a code can be fully trusted. If one sensor or supply is not fully reinitialized after reset, implausible data can set a code, even with healthy parts. When a DTC appears after battery reconnect or module scaling, don't replace parts based on codes alone. Instead, use a meter to verify each path, power, ground, and signal at the sensor or connector. A loaded voltage drop test will reveal if connection points are truly restored. Expected result: minimal voltage drop under load and plausible signals. Abnormal: voltage out of range or heavy drop points to a connection fault, not a failed part. A DTC right after a reset almost always means the ECU found something missing as it powered up. A disconnected harness, forgotten ground, or slow sensor reference. It's a system-level clue to check the basics first, before assuming the component is bad. Never swap parts based just on a DTC immediately after a reset. Code set because the ECU spotted a condition, not because it verified a broken component. Skipping simple meter tests for power, ground, and plausible signals leads to wasted time and money. Here, the technician compares the seen evidence against the next test, instead of repeating the same generic diagnostic reminder. Use this step to name the condition, the observed data, and the confirmation path that separates this scene from the rest of the workflow. This scene narrows the decision to one specific measurement or clue, then points to the next action that confirms or rejects the suspected fault. After any battery or module reset, DTCs are a starting clue, not a verdict. Always use a loaded meter test for power, ground, and signal before considering replacement. This approach catches overlooked connection problems and saves hours of guesswork. You're now prepared to approach DTCs after a battery or module reset with confidence. For more deep dive diagnostic lessons, keep learning with STEP.